Hi, this demo represents a framework that is used for reverse engineering microservices using single source of truth. The project is part of my master's program and is supervised by Dr. Sébastien, so special thanks to him. The proposed framework here uses the unified data source approach. UDS serves as a single access point, eliminating the need for managing multiple data sources. This approach enhances system understanding and simplifies maintenance. The framework is tested on microservice-based application to demonstrate its effectiveness. Specific parts of the components are reverse engineered to evaluate the practicality of the approach. There are multiple reverse engineering tools available in the market, but most of them lack flexibility for different technologies and mainly focus on specific application components. Here you can see on the slide that there are three major components of this framework: probes, UDS, and visualizer. Probes extract data from the source code and send it to UDS. UDS then send this data to the visualizer for further processing and analysis. Why we are using UDS is because extracting data from multiple sources introduces inconsistencies and outdated information, but for accurate analysis and decision making, the data must be credible, reliable, and consistent. Several UDS tools are available, but this framework utilizes a tool called Single Source of Truth, SST. It is developed by my colleague at McMaster University. SST gathers data from probes, maps system relationships, and store the information in Neo4j database, which works as a data warehouse, organizing diverse data sources into a structured format. Let's go back to the implementation and see the framework in action. This is our probes source code. This probes folder contains all the probes that we have. Right now, we only have Python probes, but any language probes can be added here as long as they extract data. Um, Once we add probes in the probes folder, we have to register them in the probes list file. This file will contain a list of dictionaries where each element uh, will contain three keys: runner command, probe file, and arguments. Runner command will obviously specify the command required to run the probe. Probe file will specify the name of the file, and arguments will be an array whose first element will be the name of the argument and second element will be the value of the argument, and so on. Uh, then this probes list script will be used by runner.py file. The first loop, it will iterate over each probes list element and create an output file, which will be site outputs folder. And then this loop will send the data generated by each probe, which will be in a JSON file, and send it to the SST server. Now let's run the SST server and register one probe. This is the SST code. We can run it with docker compose up. Once SST and Neo4j database, both of them are running, we can now register probes in SST. We can either register from the front end provided by SST, or we can directly register by sending a post request using some tool like Postman. Let's register one probe using front end. This is the front end. We can go to probes, create probe. For example, let's create endpoint probe. It has a type file. File will be path string, and it will be unique. Merge rule will be path. Save. Class. Class will have a name. String. Class will have a full name. So this is up to you. String unique. Full name will be your merge rule. Merge rule should be unique. Endpoint type, it will have field HTTP method string route string full method ID. It will be string and this will be unique, and our merge rule will be method ID. Okay, for the endpoints probe, this is enough. File will contain class will map endpoints. We can add relations. We can say contain, there will be contains relation, that file contains class, and there will be maps relation, which means class maps endpoint. Save. We have JSON preview here. Save. Now we have a probe endpoints. We are saying that the endpoint probe will contain such data, like file will have a path, class will have a name and full name, and so on, and it will uh, contain these relationships. Contains, file will contain class, class will map endpoint. Now we have to follow this structure in order to upload data to the SSD. First, let me create other probes uh, that we have. I will register all these probes. Okay, now once all the probes are registered, we can clone the repository, which is this one, pet clinic microservices. You can do git clone and clone the repository. Done. Now what we need is we need the full path of the present working directory. You can say this, copy it. Once our probes are registered, we can use the runner file to send data to the SSD server. You can say we have to give this full path of the source directory. That we just cloned. And we have to give the name of the directory, which will be name of the main directory, which will be Spring Pet Cleaning Microservices for our source code. Okay, once it's done, we can see that all our probes are processed and it is sent to the SSD server. Now we can use a visualizer. Let's connect with the remote database. This is the one that we are using with SSD, and use Neo4j browser to browse the data we just uploaded. This is one of the queries that I took from our project report, just as a sample, just to show that yes, we indeed have data in the Neo4j database. As we can see that this is a class, Neo4j database will show that the node types and their relationship. We can see that a class maps four endpoints, and we have data of each endpoint inside the endpoint node, and we have data of class inside the class node. Here we can see the different methods and their authors, and each method will have information like the name of the method and the full signature. Author will have information about their email address and their names, and we will have relationship ties. For example, top contributor will show that lines contributed by the top contributor by this author and this method is 29 and 30, and total contributions are 2 by the top contributor. And we can also see the last contributor, see the relationship here, last contributor, and last contributor will show the date, last modified date. So these are all the methods that we have in our application, and these are their authors. So this can work as a visualizer. Obviously, this is not the only visualizer that is going to work. Any visualizer that can connect directly to the Neo4j database can work. You can use third-party visualizers like Tableau, which we have already used in our project report to show some information or analysis. So that completes the whole framework. So we have visualizer here, probs here, and the SSD. All three of them combine together to make a complete framework that can reverse engineer any microservices or any large software system. Thanks for watching.